Good evening, sir.
Good evening, brother. Yeah, welcome to class. Can you hear me?
Yes, sir, I can hear you.
Oh, beautiful. So, how was the other time? How were you able to do the Agric exam and the UTME?
Mm, Thank God, sir. Both of them went through. The supervisor waited for me after the UTM.
I'm
Came
excited.
back and
Oh, good. I'm excited to hear that. I'm excited. So, thank God you were able to do that. All right. So, okay, let's hear the another person has entered. Let's hear you. Good evening.
Good evening.
Good evening, brother. You are welcome to class.
Welcome.
All right. So, today we will be considering light waves. That's the second part, the third part of the practical. So, we've treated something on mechanics, we've treated something on electricity. So, today we'll be treating something on light waves. That's what we'll be talking about. So, generally, when we say waves, so generally, what's the wave? Yes, generally, what is a wave? Can you hear me? Can you hear me?
Yes, sir.
Good,
yes, sir.
good. So generally, what is a wave?
Wave
When we
is
say
a
wave,
disturbance.
yes, I'm with you.
A wave is a disturbance that changes a state of motion.
Wave is a disturbance, yes, that passes through a medium, causing what? Causing
Cut,
temporary
cut.
change in position of the particles of the medium. Is that not?
It is, sir.
Is that not?
It
All
is.
right. Okay. So now waves are classified into how many groups?
Into two groups:
What are the two groups?
stationary, transverse, and longitudinal.
Okay. So basically, waves are classified into four groups. How many groups?
Four groups.
Yes, waves are classified into four groups. The first one, we have mechanical and electromagnetic waves. The first one, we have mechanical and electromagnetic waves. So, what are mechanical waves?
They are waves that do not require that require material medium for their propagation.
Very good. Very good. Examples? What are the examples? What are the
Wave on a
examples?
rope. Example are wave on a rope,
Yes.
sound wave, sound wave,
Yes.
and
Yes.
water wave.
And water waves. That's good. So, wave on a rope, sound waves, water wave, they're examples of mechanical waves. So, how about examples of what are electromagnetic waves?
They are waves that do not require material medium for their propagation.
Good. Examples?
X-ray, gamma
Okay.
ray,
Yes.
light, light wave, radio
Yes.
wave, infrared.
Good. Yeah. All right. So the second classification of waves, we have the longitudinal and the transverse waves. But before we go to longitudinal and transverse waves, the next is progressive and stationary waves. So what are progressive waves?
Hello, sir. You said what?
Yes, progressive standing waves. What are progressive and standing waves?
I'm hearing you well. You say what are progressive
Oh,
waves?
yes. Can you hear me now?
Yes, I can hear you.
Okay. What are progressive waves? Progressive waves. Can you hear me now?
Yes, sir, I can hear you.
Okay, so progressive waves. Can you see the screen I'm sharing, right?
Yes, I can see your screen.
Good. So that's where we are going. I'm just taking some preliminary revision. So progressive waves. What are progressive waves? The waves that travels through a medium, transferring energy from one point to another in the medium. So progressive waves are those that travels through a medium, transferring energy from one point to another. Is that taking?
Yes, sir.
All right. So the one under that is stationary or standing waves. So what are stationary or standing waves? Okay. So stationary or standing waves formed. Can you hear me?
Yes, I can hear you.
Right. So stationary, if you check these things, you will see them in your slides. But questions is not only practical they will set for you, they will also set theory questions, few theory questions. So that's why I'm doing this general revision. Is that taking?
Yes, sir.
So standing waves, they are waves that are formed. Standing waves are waves that are formed when two progressive waves travel opposite directions when they meet. When two progressive waves traveling in opposite directions when they meet. Is that taking?
Yes, sir.
All right. So what's principle of superposition? Principle of superposition. Okay, so principle of superposition states that when two or more waves, when they overlap, the resultant displacement is the sum of the displacement of each wave. Shall I say that again?
Yes, sir.
So superposition states that this was superposition that when waves when they meet at a point, the resultant displacement is the sum of the individual displacement of the waves. So again, shall I say it again?
No, sir. Taking.
All right. So that's the so I've mentioned four. That's second classification. So the third one is transverse and longitudinal waves. Transverse and longitudinal waves. What are transverse waves?
There are waves which travel perpendicular to the direction of vibration, producing it.
Good. Examples.
Example are radio wave, and light
For
wave.
yes, yes, very good. Light wave, radio waves, all electromagnetic waves, they are transverse waves. So are longitudinal waves?
They are waves which travel in direction parallel to the vibration producing it.
Exactly.
Sound wave also is an example. Hello,
Yes.
sir, can you hear me?
So sound wave. Yes, I heard you. Sound wave is a longitudinal wave. That's very good. All right. So we've done well. The last one is okay. We've spoken about standing waves. So we won't go into details. You can check the slide for properties of longitudinal waves. That is rarefaction and compression. Do you remember?
Yes, sir.
Do you remember?
Yes, sir.
So then properties of progressive waves, we have the crest and the trough for transverse waves. For stationary waves or standing waves, we have the node and the antinode. Do you remember?
Yes, sir.
Yes,
Then the
sir.
general, what's the general wave equation? Yes, what's the general wave equation? Is that Faith or Elizabeth? What's the general wave equation? So the general wave equation is V equals to F lambda. Shall I say that again?
No, sir.
No, sir.
Okay, so that's for, okay, so what are the properties of waves? Properties of waves.
Reflection, refraction, diffraction, interference.
Again, is that Elizabeth? Are you?
No, sir. It's faith.
Faith. Oh, Faith. Yes. So what are the properties of waves again?
Reflection, refraction, interference, diffraction.
So very good. So what's reflection? Yes.
Is the bending of light waves when they hit an obstacle.
The what?
The bending or throwing back of light waves when they hit an obstacle.
So the ability of light to be sent back when it, I say ability of light, ability of a wave hitting an obstacle. Ability of a wave to be sent back after hitting an obstacle. That's reflection. So what are the laws of reflection? Laws of reflection. Very important. Yes, laws of reflection. Yes, anybody, laws of reflection.
The angle of incidence is equal to the angle of reflection.
These are likely questions that I'm asking you. Questions you should expect. Please, am I audible enough?
Yes,
Yes,
sir.
sir.
All right. Bro, you are not talking again. Is it because Faith is talking now? Agu?
No, sir.
Is it? Uh-huh. Yes, I'm happy that she's talking too. So please, you two should talk. Do you have any ideas
Yes.
of reflection? Okay, so should I tell you or you want to try?
Angle of incidence must be equal to angle of reflection.
I think your application or your network is not good again. Okay, so can you hear me?
Yes, I
Yes,
can hear
sir,
you.
we can hear you.
All right. Laws of reflection. I said we have how many?
I can't hear anything. Is it my network?
Is your network? Is your network? Faith, can you hear me well?
Yes, sir, I can.
Is your network? I guess you've changed your location. Okay, so loss of reflection. Number one, the incident ray, and the normal at the point of incidence all lies on the same plane. Shall I say that again?
No, sir.
Okay, so do you want to tell us the
Yes, sir,
second
please
one?
say it again.
Shall I say the second one?
No, sir. No, sir.
Okay, so the second one, the angle of incidence is equals to the angle of reflection. The angle of incidence is equals to the angle of reflection. Shall I say that again?
No, sir.
All right. So if this is the incident wave, this is the reflected wave, this is the normal. So this is alpha, this is beta, this is gamma, and this is phi. Let me redo this. This is gamma. So which of them is angle of incidence? Which of the four angles is the angle of incidence?
Alpha.
So alpha is the angle of incidence. So which one is the angle of reflection?
Gamma.
So gamma is the angle of reflection. So gamma plus phi, this is phi. Gamma plus phi is what?
90 degrees.
90 degrees. How about beta plus alpha?
90 degrees.
Very good. So that's why we call this one, we call it normal. Very good. So those are the laws of reflection. So let's go to light waves now. So let's go to light. No, before we narrow it down, what's the second property you mentioned?
Refraction
So what is refraction?
is like the change in speed or bending of light waves when they hit an obstacle.
Very good. Ability of a wave to navigate, to bend around obstacles or to pass holes. So that's no That one is diffraction. That one is DI.
Diffraction.
Yes, a fraction is the ability of a wave to bend when they pass through media of different densities. Ability of a wave to bend when they pass through media of different densities. Shall I say that again?
No, sir.
For refraction, there will be change in velocity. The wave will bend, then wave has to pass through media of different densities. So, for example, when light passes from air, this is air, when it passes from air to glass or from air to water. Can you see my drawing?
Yes, sir.
So this is normal. So this is the incident ray. This is the reflected ray. This is the angle of incidence. This is the angle of refraction. So what are the laws of refraction?
The incident ray, the reflected rays, and the normal ray at the point of incidence all lie on the same plane.
Very good. But something is, it said reflected ray.
Oh, the incident ray and the refracted ray. Sorry. Hello,
So
sir. Can you hear me?
again, yes, I can hear
The,
you. Can you
the,
restate it one more time?
the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane.
Very good. Very good. So the second law,
The ratio of the sine of the
The
angle of
ratio
incidence.
the ratio of the sine of incidence to the sine of refraction is equal to the refractive index.
okay. So from the diagram, we can see a wave is passing from air to glass. Air and glass, which one is denser?
Glass.
Did you hear me? Can you hear me?
Yes, sir.
Yes, sir.
All right. So air and glass, which one is denser?
Glass
Glass.
is denser.
Which one is denser? Is it air or glass?
Glass is denser.
Glass is denser. So if light is from air to glass, which one will be greater? Third ray.
Sir, could you repeat yourself?
Shall I say it again?
Yes, sir.
So I said if light
Yes, sir.
passes from air into glass, which one will be greater? Is it angle of incidence or angle of refraction? Which one will be greater?
Angle of incidence.
Why did you say angle of incidence should be greater?
Then, sir, uh,
Yes,
the angle of refraction will be closer to the normal, thus making it have a smaller angle.
that's true. So since the wave is going from less dense to a denser medium, so angle of refraction will be lesser than angle of incidence. Is that taken?
Yes, sir.
All right. So if light is going from glass to hair, which one will be greater?
Angle of refraction.
All right.
The angle
So
of refraction.
very good. So the third property of waves. What's the third one?
Diffraction.
So what's diffraction?
The ability of wave to bend against obstacle.
Yes, ability of a wave to bend around obstacles or to pass through a tiny hole. Yes, that's true. So what's the fourth one?
Interference.
Interference. So what's interference?
Is the property of waves when waves with the same amplitude, frequency, and wavelength traveling in the same direction superimpose each other.
Yes, that's a good one. So when waves traveling in the same direction superpose or overlap one another, so that's interference. Then the last one is polarization. Waves that exhibit polarization. Is that taken? So what are the waves that exhibit polarization? What are they called? The waves that do not exhibit polarization, what are they called?
Longitudinal waves do not exhibit polarization, but transverse waves do exhibit polarization.
Yes, so transverse waves, they undergo polarization, while longitudinal waves do not undergo polarization. So that's a good one there. All right. So I think we
Sir,
can
but
move
what
to the
is
next one.
polarization?
What did you say? Okay, so let's quickly, these are the likely areas question will come from. So who is reading the first slide?
So what is polarization?
Can I answer it?
The first
Yes.
slide, who is
Yeah.
reading?
Sir, they're asking question now.
Oh,
Sir,
okay,
please read
okay.
the question.
Yes, what's the question?
They're asking what is
What
polarization.
is polarization?
Polarization is a process of making transverse waves to travel in a direction parallel to the vibration of the medium. Shall I say that again?
Yes, sir.
Yes. So polarization is the process of making transverse waves to travel in a direction parallel to the vibration of the medium. Shall I say that again?
Okay, thank you, sir.
All right. So the slide now. So who's reading the first slide?
So scroll down.
Okay.
A rail,
Light waves.
light wave.
Yes.
Oh, scroll down, sir.
Okay. Have you seen it?
I can see now. Light waves
All right.
is a visible source of energy. It is a wave motion. It is an electromagnetic wave. It travels at a speed of 3 exponential 8. It has 3 exponential 8 meter per second. It has a very short wavelength of about 5 exponential 7 meter. The sources of light include the sun and the stars, a candle, electric torch, the electric lamp, incandescent, arc light, and fluorescent light.
Okay. Do I need to explain anything there?
No, sir.
No,
All right.
sir.
Next slide.
Sources of light wave. There are various sources of light. Natural and artificial. Natural source of light include the sun and the stars. Artificial source of light are candle, electric torch, electric lamp, incandescent, arc light, and fluorescent light.
Very good. Do I need to explain anything there?
No,
No,
sir.
sir.
Yes. The reason why we are going through this slide is because of that. The principle that they will ask you to use is likely your question is coming from refraction of light. So that's why I'm going through all this again with you. So next slide.
Sources of light waves. When light falls on luminous surfaces, it may be absorbed, transmitted, or reflected. Sometimes a combination of the above processes may occur.
Yes, can another person read?
So please scroll down.
Okay, down. Okay.
I can't still
So can
see
another
the
person
next
read?
the next slide.
How about now?
I can
How
see.
about
So
now?
I
Okay.
can see.
Light ray and beam. A ray is the direction of the path in which light is traveling. It is represented by a straight line with an arrowhead. A beam is a collection of two or more rays of light. Beams can be parallel, convergent, or divergent.
Very good.
Should I?
Now, a question they may ask you is that they can ask you to define a ray of light. They can ask you to define a beam of light. But the question I want to ask you is that what's the difference between a ray and a beam of light? So that's the question I want to ask. Yes, who is answering?
Sir, please, could you repeat the question?
What is the difference between a ray and a beam of light?
A beam is like collections, a collection of more than one ray.
Why a ray
Yes.
direction of light?
So a ray of light is direction of the path in which light is traveling, while a beam is a collection of two or more rays of light. So, all right, next slide. Next slide.
Parallel, convergent, and divergent beam. A parallel beam is two or more rays traveling in the same direction but can never intersect each other. A beam of light is said to be convergent when they meet at a point. The divergent beam occurs when a collection of light rays has the same source is spread out apart.
Okay, so that's very important because in the practical, you'll be considering um, incident ray, refracted ray, you'll be considering the emergent ray. So that's why these definitions are important. Okay, next slide.
Parallel, convergent, and divergent. Oh, okay. Rectilinear propagation of light.
Yes.
The phenomenon of light traveling in straight line is known as rectilinear propagation of light. It can be demonstrated by placing a candle flame at the end of a straight pipe, and the process repeated. Nothing will be seen at the other end. Okay.
Yes, next slide. If the pipe is then bent,
If the pipe is then bent and the process repeated, nothing will be seen at the other end. This clearly shows that light travels in straight line. Two natural effects that result from the rectilinear propagation of light are the formation of eclipse, the formation of shadow, rectilinear
yes. So
propagation of
another
light, the
likely
principle of
question
operation.
from another likely question here on the practical is what is rectilinear propagation of light? Or they may tell you that on what principle talks about light traveling in a straight line. So what principle is that?
Rectilinear propagation of light
So what is rectilinear propagation of light?
is the phenomenon of light traveling in straight lines.
It means that light
So a phenomenon by which light travels in a straight line. So please take note of these likely questions. So shadow, eclipse, PO camera. So the next one is linear magnification. Read that slide on linear magnification? Yes, who is reading? Can you hear me?
Yes, I can hear you.
Yes, sir.
Yes.
Yes,
Please read
I
the
can hear you.
slide on linear
Magnification is defined as the ratio of the size or height.
So please pay attention to the definition of magnification. So what comes first is the image. So image size over object size or image distance over object distance. Is that taken? So very good. All right. So we can move on to the next one. So spoken about. So now let's now come.
A question on that polarization.
Okay, yes, go ahead.
So you said that polarization it has to do with waves traveling parallel, right?
Yes, you are
And
making
that
waves. You are making waves that travels perpendicular to the vibration of the body which they travel. You now make them to now travel parallel. It's like changing transverse waves to longitudinal waves. That's polarization. You are changing transverse waves to longitudinal waves. Yes.
sir, please, I didn't get you.
Come again.
I didn't hear what you said.
You didn't what?
Hear what you said. Sir, can you hear me?
Now I can. I think I'm hearing you faintly now.
Okay,
I
I
didn't
said
hear
that
your
the
question.
explanation you just gave now, I didn't get it.
At the moment, I can't hear you. At the moment, I can't hear you.
I
I
can
don't
hear
know.
you
Can
now,
you
sir.
hear me?
Yes, I can hear now.
Sir, please, can you hear me?
Faith, what's happening?
Sir, I said that the explanation you just gave now, I didn't get it because I was not hearing you audibly.
Okay, can you hear me audibly now?
Yes, sir, I can.
Good. So I said that polarization, simply put, is changing transverse waves to longitudinal waves. You know that transverse waves, they travel in a direction perpendicular. Okay, so let me use illustration. Are you with me?
Yes, I'm with you.
Good. And you can see my whiteboard.
Yes, sir.
Yes,
Very
sir.
good. So transverse waves are usually of this form. That's transverse waves for you. Is that taking?
Yes, sir.
So by the time a transverse wave is coming and you now put a Polaroid in front. You put a Polaroid in front of the transverse wave, so it will not be able to keep traveling like that. It will now come out like this. So you have turned it from being transverse to being longitudinal. You have turned it from being transverse to being longitudinal. Did you pick that?
Yes, sir.
All
Sir,
right.
please, does this mean that longitudinal waves do not undergo polarization because they are already traveling in a parallel direction?
Sound waves, they are already polarized. They cannot be polarized again. So that's why I said that polarization is not a property of longitudinal waves. It's only a property of transverse waves. Should I say that again?
No, sir, it's clear. Thank you, sir.
All right. So can we move on now?
Yes, sir.
All right. So let's go to our slide. So yes, the first slide who is reading. Yes, who is reading?
So is that the first slide or the second slide?
The first slide. The first slide.
Refraction of light. Refraction of light is the bending, that is changing direction of light from the normal as it passes from one medium to the other of different densities. This is due to difference in the speed of light in different media.
Good. Do you want me to explain anything there?
No, sir.
All right. Now, did you see in that diagram, did you see incident ray in that diagram?
Yes, sir.
Did you see refracted ray?
Yes, sir.
Did you see emergent ray?
Yes, sir.
So if they give you something like this, how will you measure angle of incidence? How will you measure angle of incidence?
Can use protractor, sir.
Again,
With protractor.
good. You use a protractor. So I believe you know how to use a protractor, right?
Yes, sir.
Do you know how to use a protractor?
Yes, sir.
Very good. So if they ask you
Yes, sir.
to measure the width, width of the glass, how will you measure it? Width, width of the glass, how will you measure it?
We
Should
can
I
use
say
ruler.
that again?
No, sir.
You use
We can
what?
use ruler. Ruler.
You use rules. Is that not? You use the ruler.
Yes, ruler.
Good. So now if they ask to measure the refracted angle of refraction, how will you go about that?
Also use protractor.
You also use a protractor, and your answer will be in what?
In degree.
Very good. So it will be in degree, then your answer will be in one decimal place. Should I say that again?
No, sir. Taking.
Very good. Very good. So there are still more stops here. So the next slide,
Sir, please, how many decimal places?
one decimal place.
Okay, sir.
Yes.
Sir, please, how do we find the emergence angle of emergence?
Yes. Angle of emergence, you can just draw. You use your protractor to draw 90. You know that the block, this one, what type of block is this? This block we are using,
Perspex block.
this is rectangular block. What did I say?
block.
So this is rectangular block. So the angle, so you will place your protractor on that base, the base of the block. Can you see a straight line at the base of the block?
Yes, sir.
So you place your protractor there, then you now measure it to the emergent ray. Should I say that again?
Yes, sir.
That base, the base of the block. Can you see my whiteboard?
Yes, sir.
Yes, sir.
This is your rectangular block. This is the normal, this is the incident ray. This is the reflected ray. This is the emergent ray. So you measure this angle. So usually the emergent are usually the same because for the incident ray, light is entering from air to glass. For emergent ray is coming out of glass into. Did you process what I'm saying? Did you process what I just said?
Yes, sir. Yes, sir.
All right. So on this line, you place your protractor here. The base of the protractor, you place it here. Then you read this angle. You read this angle from your protractor. That's the angle of emergence. Should I say that again?
Sir, will we turn the protractor upside down?
Which,
Will we turn the protractor upside down?
yes, you turn the protractor upside down. The most important thing is that make sure that the middle of the protractor, that middle point of the protractor is here. Do you see where I circle with red ink?
Yes, sir.
You didn't see where I circle with red ink.
Yes, sir.
Okay, so
So is that place acting as the normal?
come again.
Is that place that you circled with red acting as the normal?
Yeah, it's acting at the normal. That's like angle 90. So you now measure from 90, or you place your normal here. Did you get what I'm saying? Then you now measure this way. Do you get what I'm saying?
Yes, sir.
Okay. So let me give you another one. Okay, can you see?
Yes, sir. I can see
Sir,
a bit
it's
bright.
faint.
All right. Now, uh,
Yeah, I
did
can
you
see.
see L
Yeah,
and
I can see
M?
brighter now.
Yes, sir.
Yes, sir.
Now that L and M. Now, okay, let me start. S P PSRQ is a rectangular glass prism. Shall I say that again?
No, sir.
All right. Okay. So I think I should allow you to read to stick better. Okay, please read.
In determination of the
Refractive,
refraction. Of
Yes.
it.
refractive index. Aim.
Yes.
Determination of the refractive index of a transparent glass block. I. By ray tracing. By real and apparent depth. Apparatus. Rectangular glass block. B.
Good.
Drawing board. 4 pins.
Good.
Drawing papers. Traveling microscope.
Yes.
Lycopodium or chalk dust.
Now, okay, so I'll come back to this. Let's move on with the story because I see some things they might ask you to state. So, next slide, slide 4 now.
Law
Slide
of,
4. Who's reading slide 4? Yes.
yeah, law of refraction. The incident rail, ref- refracted rail, and the normal at the point of incidence all lie on the same plane. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of media. Snell's law.
Good. So,
And
which one is called Snell's law? If they ask you to state Snell's law, what's Snell's law?
law of refraction.
No, law of refraction is not Snell's law.
Yeah, I will state the ratio of the sine of angle of incidence.
No, read the slide again.
The incident ray, refracted ray, and the normal at the point of incidence all lie on the same plane. The ratio
Good.
of the
So, which of the two laws is the Snell's law?
The second law.
Second law. So, if they ask you to state Snell's law, what?
The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of media.
Faith, maintain this present location. Your voice came out where? Is that taken?
Really? Okay, sir.
Yes. One more time.
Yes, sir.
So,
The
Snell's law.
ratio
One
of the
more time.
sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of media.
Very good. So, maintain this location. So, that's Snell's law. So, those are things to note. Those are things to cram. Very good. Yes. Read on. So, that,
As
yes. Read on.
As the ray of light travels from air to glass, the refractive index can be written as refractive index from air to glass is equal to sine I over sine R. From the principle of reversibility of light, refractive index from air to glass is equal to inverse of refractive index from it's supposed to be glass to air.
Yes. The glass to here. That's good. So, that's principle of reversibility. So, what's the formula for refractive index?
Sine I over sine R.
So, what does I stand for?
angle of incidence.
Angle of
Good.
incidence.
What does R stands for?
Angle of refraction.
Good. So, how do you know the angle of incidence? How do you know the angle of refraction?
You mean from the prism?
When you
From
are
the
given a diagram, yes, the diagram in the prism, in prism. So, how do you know that this is angle of incidence, this is angle of refraction.
I'll say that angle of incidence is always up, while the refraction is down.
The angle of incidence is also like the angle the incident ray made with the normal, while the angle of refraction is the
Good,
angle the refracted ray made with the normal.
good. So the angle between the incident ray and the normal, because they will ask you to measure angles. They will ask you to measure a particular angle for and refracted ray. So you need to know the difference and where to measure. So that's that. Okay, slide 5 now.
Sir, please, I would like to ask you a question on this refractive index.
Yes. Yes, go ahead.
Sir, in our main exam, the OBJ, there was this question. They gave us the refractive index for A, they gave us the velocity for A, and then they gave us the refractive index for B and said that we should find the velocity for B. So how should we have solved it? Like, if we had solved, which formula should we use?
Speed of light in air over speed of light in glass will give you refractive index. Is that taken?
No, sir.
Can anyone hear her?
Transmitted.
Okay, someone can help
Sir,
us.
sir, can you hear me?
Not well, not so well.
Whoa. I said that I didn't get the explanation
I
you
can hear you
gave.
speaking. Hello, sir.
Did
Can
you
you
hear
can
what
you
she
hear
said?
us? Yes, she said you should repeat the
Okay, so
explanation
refractive index,
over the question she asked.
yes, is speed of light in medium 1 divided by speed of light in medium 2. So medium 1 is the medium from which light is coming from, and where it is entering is medium 2. So speed of light in medium 1 over speed of light in medium 2 will give us the refractive index.
Sir, I used that
Did
formula,
I
but the answer
answer?
I was getting was not in the option.
I really wish you could maintain your initial position, Faith. Okay, who had
Sir,
her?
I'm still there. Oh.
I don't know what happened.
Sir, can you hear me?
Not so well.
Should I shout? Can you hear me now?
Yes, I can hear you. Okay.
Okay, I said that I used that formula, but the answer I got was not in the option.
What was the question?
I can't remember vividly, oh, but what I remember that the parameters we were given the refractive index for medium
Question
A,
was
we were given the velocity for medium A, we were given the refractive index, or is either the refractive index or the velocity for medium B, and then they now told us to find the refractive index for medium B.
And what likely they have used in that question is likely principle of reversibility. From what you are saying you were given, is likely is principle of reversibility you are supposed to use. Principle of reversibility to glass is equals to 1 over refractive index of light from glass to air. Did you process what I've just said? So can we move on now?
Yes, sir.
Okay, so let's move on. So yes, next slide, slide 5.
Real and furthermore, the refractive index from medium air to glass is equal to speed of light in air, medium 1, in incidence medium, over speed of light in glass, medium 2, refractive medium. As a result of
So
refraction, the bottom of a
Good.
clear. So what did you say?
your present location, your voice is coming like the voice of faith, and I like that.
Okay, thank you. Okay, so the bottom of a clear river or pond appears shallower than it really is. A rod or spoon appears bent or broken when it is partially immersed in water or any liquid. Letters in print seems to be nearer when we place a thick block of glass over them.
Good. So they can ask you for instances of refraction. So these are instances of refraction. Is that taken?
Yes, sir.
Good, brother. So give me 3 instances of refraction.
Uh,
Yes,
sir,
yes,
insert is how
yes. Of refraction from slide 5.
the bottom of a clear river or pond appears shallow than it really is
Due to what?
due to refraction.
Very traveling from air to water. Is that taken?
Yes, sir.
The second one,
Network has removed your stream. This network.
the second one,
My network has removed your stream. I can't see your screen. I can see now. A rod or spoon appears bent or broken when it is partially immersed in water or any liquid.
okay, have you seen something like this before?
Yes, I have.
Good. The
Okay.
third one,
Lat- Letter in print seem to be nearer when we place a thick rod of glass over them.
good, good. Next slide.
Total internal
Real
reflection. Read on faith.
Slide 6.
Real and apparent depth. A thick slab of glass appears to be only two-thirds of its real thickness when viewed vertically from above. Similarly, water in a pond appears to be only three-quarters of its real depth. Rays from a coin at the bottom of a bucket of water are refracted away when they leave water and enter the eyes. They appear as if coming from a visual image, which is at apparent depth, while the actual depth of the bottom remains and is referred to as real depth. Refractive
Yes.
index equals real depth over apparent depth.
Very good. So how many definitions do we have for refractive index now?
Two.
How many formulas do we have for refractive index now?
It's two now. No
Two,
one.
sir.
How many formulas do we have for refractive index?
I'm
Two
seeing one.
formulas,
No,
sir.
no one.
What are they?
Sine of angle of incidence over sine of angle of refraction is equal to the refractive index, and is also equal to real depth over the apparent depth.
Sine I over sine R, or real depth over apparent depth.
So how many formulas altogether?
Two formulas.
Two formulas.
Is it two or three? Sine I over sine R,
Oh yes,
speed
it's
of
three.
light in medium 1 over speed of light in medium 2, then real depth. Is that taking?
No, sir.
All right, next slide.
No, sir. We
Please,
said no.
sir, we didn't get
Oh, you
it
said
to.
no. Okay,
Yes, we said no.
okay. So I said that how many formulas do we have for refractive index?
Three.
Two formulas.
So what's number one?
Sine I over sine R.
What's the second one?
Real depth over apparent depth.
What's the third one?
Velocity of
One
light in
over.
medium 1 over velocity of light in medium 2.
Okay, so is that clear now?
Sir, please, that third instance in slide 6, I didn't understand it.
Which one?
In slide 6, they gave three instances of. Uh, Sir, can you go back to the slide?
Yes, are you there?
Yes, sir.
Yes, I'm back to the slide. What's your question?
Sir, I can't see the slide.
You have to log out and log in again. Can you see now?
Yes, sir.
Yes, I can.
No.
Very good. So what's your question?
My question, I need you to scroll down. Yeah, the instance for the coin. I didn't understand it.
Which one?
You know that these real death and apparent death, they gave three instances. That third instance with the coin inside a bucket of water, I didn't understand it very well.
Please, if you had that well, can you ever reproduce? Please help Faith reproduce her question.
She said she didn't understand the third line of the real and apparent debt. That is, raised from a coin at the bottom of a bucket. You should explain better.
Okay, so rays from a coin at the bottom of a bucket of water are refracted away when they leave water and enter the eyes. Yes, it's trying to explain that if you throw a coin inside water in a bucket, it will look as if the coin is almost floating, despite that it's at the base of the bowl, at the base of the bucket. Have you noticed that before?
Yes, sir.
No, sir.
Yes, so that is what we call refraction. It looks as if the coin, it is when you now put your hand inside the bucket, that's when you now notice that the coin is on the base. To look as if the base of the coin is not on the floor. To look as if the base of the coin is closer to the surface of the water. Have you noticed that before?
Yes, sir.
Yes, sir.
Yes. So
Especially shallow water.
it is due to refraction. Now, this is what we are saying. The real depth is the depth of the bucket. Did you pick that?
Yes, sir.
The apparent depth is where the coin appears to be, other than the base of the bucket. Where the coin appears to be other than the base of the bucket. That's the apparent depth. Is that taken?
Yes, sir.
Okay, can we move on now?
Yes, we can.
Yes, sir.
Good. So slide 7 now.
Total internal reflection and critical angle. When light passes at a small angle of incidence from a denser to a less dense medium, example from glass to air, there is a strong refracted ray. There is also a weak ray reflected back into the denser medium. As the angle of incidence increases, the angle of refraction also increases. At a certain increase of the angle of incidence, the angle of refraction is 90 degrees. This angle of incidence in the denser medium, for which the angle of refraction is in the less dense medium, is 90 degrees, is referred to as the critical angle. See.
Good. Next slide. Next slide.
Total, total internal refraction. Total internal reflection and critical angle. For an angle of incidence greater than C, the refracted ray disappears and the entire incident light is reflected back into the denser medium. At this point, the ray is said to experience real total reflection. Example of total internal reflection is the mirage on the road, where the
Yes.
refractive densities of one air is less than that of co-air and light meets a layer at a critical angle. It suffers total internal reflection.
Good. Next slide.
Total internal reflection and critical angle. The angle of incidence is less than critical angle. Rays are refracted with a very small reflection. The angle of
Yes.
incidence is equal to critical angle. Ray emerges along the edge of the block. The angle of
Yes.
incidence is greater than the critical angle. The ray is totally internally reflected.
Very good. Very good. Next slide. Slide 10.
Triangular prism. The angle between the incident ray and the emergent ray is known as the angle of deviation. The angle of
Yes.
deviation decreases as the angle of incidence increases. The
Very good.
refractive index.
Can you repeat that?
The angle of deviation decreases as the angle of incidence increases.
Good. Then the refractive index formula.
U equals to sine AD over 2 over sine A over 2.
Now, most of the glass prism you'll be given is an equiangular triangle. What does equiangular mean?
Three sides, the three angles are equal.
Good. So in that case, A will be what?
60 degrees.
Good, 60 degrees. So A plus DD is the angle of deviation. So you can use that to also calculate refractive index for triangular prism, making 4 formulas. Is that taken?
Please, what is the angle of deviation in the diagram?
All right, that's a good one. Now, did you see the incident ray from K? Did you see K?
Sir.
Did you see K?
Sir.
Did you see K?
Yes, I can
Sir.
see K,
I can see it.
Very,
the red line.
very good. So that's the incident ray. So the angle between K is I1. You see I1?
Yes, sir.
So that is angle of incidence. All right. Now, can you see R1 and R2, the yellow line? Yellow line. Are you there?
Yes, sir, we are.
Can you see the yellow line?
Yes, sir.
So the yellow line, that's the refracted ray. The yellow line is the refracted ray. Can you see that?
Yes, sir.
So R1 is the angle of refraction. Did you see that?
Yes, sir.
Now, did you see R2?
Yes, sir.
Did you see S? S, did you see S?
Yes, sir.
So now the blue light and K, did you see S and K?
Yes, sir.
So the angle between KQ and S, that's angle of deviation. Should I say that again?
Yes, sir. Please do.
Did you see the blue line S?
Yes, sir.
Did you see the line KQ, dotted line KQ?
Yes, sir.
Did you see the angle of where the two of them met?
Yes,
Sigma.
sir.
That's the angle of deviation. Shall I say that again?
No, sir.
All right. So let's just take. So what's length formula?
1 over U plus 1 over V.
equals to 1 over f. So let's consider a clip on YouTube. Then we now come back to a particular question. Then we can call it a day from there. Then we continue tomorrow. So please put down that formula for rectangular glass block. Refractive index of rectangular glass block. Can you hear me?
Yes, sir.
Yes, sir.
Good. So it is my voice you will be hearing. You won't hear
The last one
the sound. Eh?
the last formula you showed us, right?
Yes, that's sine A plus B over 2 over sine A over 2.
Taking.
Taken, right?
Yes, sir.
Good. Are you there? Hello, are you there? Can
Yes,
you hear
sir.
me?
Yeah.
Yeah. Yes, I can hear you.
Yes, sir.
Can
We
you see the
can.
screen? See the screen I'm
Yes, I can
sharing?
see. Yes, I can.
Yeah.
Good.
After tutorials.
So they will give you a drawing board. They will give you drawing sheet, A4 paper. They will give you optical pins. The optical pin may not necessarily look like this. The other one may look like a long needle. Do you know a needle? You know a
Yes, sir.
needle, right? Yes.
Yes, sir.
So the optical pin they will give you may not have these yellow and red stuffs. It will just be the other one that looks like a long needle. Of course, you are supposed to go with your ruler and mathematical set. You're supposed to go with your long ruler and mathematical set. So you pin your your A4 paper, you pin it to the board. You pin it to the drawing board. But in this case, you are likely to use yes, they should give you a drawing board. You're not supposed to use the table. So that's rectangular glass block. Can you see the rectangular glass block?
Yes, sir.
Yes,
So
sir.
so you will have to trace the rectangular glass block with a pencil. You trace it with a pencil. So that's what it's doing. So in the instruction, they will ask you to label the trace either as ABC or PQRST or something. So that is the labeling. It has just labeled A, B, C, D. So, like I asked, that if they ask you to measure the width or the breadth or the length of the glass block, what instrument will you use to do that measurement?
Ruler.
Very good. A meter rule. And when you are using meter rule, your answer will be to how many decimal places?
1 decimal.
So it's going to be 1 decimal for cm. But if it is mm, it will not have any decimal. If you are using meter rule for cm, 1 decimal place, if it is mm, it will not have any decimal. So can you see how he's using protractor to draw number now? So number is angle 90. Is that taken?
He only measured AB and he did not measure BC,
Yes, it's
the
what
other side.
instruction asks you to do. It is where instruction asks you to measure that you will measure. Is that taken?
Okay, sir.
Yes. So please, it is what the instruction asks you to measure. In fact, this one, he measured AD. They may ask you to measure the thickness of the glass. You know that the thickness of the glass will now be AA. Can you reason with AA?
Mm, how?
AA means that the A facing you and the A at the back. You
I
didn't
don't
get that.
understand. I didn't, sir.
Can you see my whiteboard? Are you
Yes, sir.
there?
I can see. Yes, yes, I'm here. I can see.
This is A, B, C, D. So this is A prime, B prime, C prime, D prime. If they ask you to measure A and A prime, that's thickness of the prism. Shall I say that again?
Yes, sir.
Yes, sir.
If they ask you to measure A, A and A prime, you should measure the distance between A and A prime. That's thickness of the prism. Shall I say that again?
No, sir.
All right. So can we return to our video?
Yes, sir.
So are you flowing with what he's doing? or you want me to make some explanation?
We are following, sir.
So now what he just did is that in the instruction, they asked him to measure a particular angle. So that is what he used protractor to measure. Did you pick it, or I should show you that
Yes,
again?
I got it, sir.
Very
No,
good.
sir, we understand.
So I is 60 degrees. So place two optical pins on line PO. Replace the prism on its outline. Are you there?
Yes, I'm here.
Oh, good. So it's replacing the glass prism now. So now, what is doing here? Can somebody read the instruction at the base of the video?
Place two other pins at T.
Yes,
Looking, looking from the side DC of the prism. Place two
yes,
other pins at T and S, such that all the four pins appear to be in straight line when viewed through the prism.
very good. Now, what does that mean? It means that somebody wrote something in the board and they now draw a straight line on the board.
I will meet yourself.
Can you hear me?
Yes, sir.
So now when you are now, they now give you a glasses. They said you should now view what is written on the board again.
Sir, please, can you start all over again to in your illustration?
Now, I want to explain this point. Can you read what is at the base of the video?
Looking from the side DC of the prism, place two other pins at S and Q such that all the four pins appear to be in straight line when viewed through the prism.
Very good. So what you are doing here is that when you bend to this side of the prism, can you see the optical pin? Can you see those red stops from the prism inside the prism? Can you see that?
Yes,
Yes,
sir.
sir.
Good. So you will now take another pin to block those pins. So that's what they are about doing now. Did you see that? Did you see that? He's trying to use
Yes, sir.
another pin. Can you see? Can you see? Good. So you see that you won't see those other pin in the glass. You won't see them again by the time you put your own. So that is what you are asked to do. Did you see what just happened? Did you
Yes,
see
sir.
what just
Sir,
happened?
for when we are performing our own practical, how will we be
Yes.
able to see this thing?
You will see it just like this same way this person is seeing it. Are you with me?
No, sir, I still understand.
Okay, so let's. Do you know how to see this one, this particular one?
I'm seeing it.
We are seeing,
She has a bad network.
yes. Brother, do you understand what I'm saying?
Yes, I do.
Oh, good, good.
She needs to understand that she needs to see it from the other side,
But
not as
through
the
the
video is
glass,
showing it. Yes, through the glass prism from the other side.
good, good. Yes, he has used the third one to block the first two that is seen in the glass prism. He now used the fourth to block the first three. It's just trying to show that light travels in a straight line. It's inner propagation of light. So he's about to join those 2 points. Did you notice that?
Yes, sir.
Very good.
Please mute your mic.
So did you see the way he joined them?
Yes, sir.
Good. So he has picked the angle of refraction. Did you see how he picked the angle of refraction?
Yes, sir.
Now line of angle and the line of incident ray, he extended it with dotted lines because he want to pick his lateral displacement. Is that taken? So that's why he's using dotted lines. Did you pick that?
Yes. Can
Good. So what do we call QS? QS is called what?
QS?
QS. QS is what?
Is it OS or QS?
QS. He has covered it, but pay attention to what you want to measure now. But can you see S? Can you see QS now?
Yes, I can see.
Yes. So what do we call that line?
Angle of deviation.
That's emergent ray. Emergent ray. QS is emergent ray. Okay, so did you see how he pick that lateral displacement D? Did you see how he picked
Yes.
that? Very good.
Yes, sir.
So he now measured the length, the lateral displacement, then he's about to measure and record. Did you pick that?
Yes, sir.
Good. So he's recording angle of refraction. Did you see how he picked angle of refraction? Did you see how he picked angle of refraction?
Yes, I've seen it.
Oh, good. So it's showing how to record the values. So when you are recording your own I and R, are you with me?
Yes, sir.
He didn't put decimal place. So if you are recording I in degree, how will you record it?
Sir,
Take
I
what?
don't
Can you repeat the
understand.
question? Hello, sir.
Yes, brother, I'm with you.
Can you repeat the question?
Now, he has recorded I and R. If you are to record your own, how will you record it?
The way he did.
So when you are recording your own, you won't just put 60. You will put 60.0. Should I say that again?
No, sir.
No, sir.
How about R in degrees?
35.0.
Very good. So that's D in cm. I've explained that. Is that not?
You have.
Good. So that is
Oh,
one decimal.
can we also add zero in the four?
No, I said for cm, one decimal place. For mm, no decimal place.
He's still going to measure and draw other line for incident and reflected ray, right?
Now, in the question, they will specify everything they want you to measure. So that will now determine how many columns your table will have. Do I make a point?
Yes, you do.
So we can move on, right?
Yes.
Sir, please, what is the name of this video? The title.
Okay, so you can screenshot now, right?
No, she's asking the name of the video, the name of the
Yes, it's on
producer.
it. Can you see it now? Alpha Beta tutorial.
Okay, sir. Thank you, sir.
You're welcome. Okay, so let's see how far we could go. So can you read what's at the base of the video?
Plot a graph of sine I R over cos R on the vertical axis and D on the horizontal.
Okay, so that's your assignment. That's your what?
Assignment. So I submitted the first one you gave us.
Oh, I didn't see it. You can
Sir,
remind the
please,
attendee.
did you hear me?
Come again, Faith. Faith, what did you say?
It was, what did you say?
I said in this physics practical, how many practicals are we doing? Is it just one on this light?
On this slide, they will give you 3 questions, one on mechanics, one on electricity, one on light. You will answer 2 out of the 3.
Okay, sir. Thank you, sir.
All right. So, Faith, have you submitted any graph so far? Any graph exercise?
Hello, sir.
Yes, brother.
The first one you sent, while trying to plot it, in I was having difficulty deriving scale due to there was um the second one, it was on, was it, yes, on electricity, was bearing 0.02, and at the top was now bearing 0.004. So it confused me in driving scale.
Okay. That one, the scale you will use. So what we will do is that remind me tomorrow so that I can check the least value and the highest value. Then I will tell you the scale.
How can I remind you?
I mean during class tomorrow.
Okay.
Yeah, just make sure that your graph book is with you. Your graph book and the
I'm,
table.
I'm even with it here.
Okay, you are with it. So what's the smallest value? What's the highest value?
I didn't plot that first one. I plotted the second one, sir.
I mean, which one do you want me to suggest scale for?
Okay. It was the first one, sir.
So that first one, which of the axis?
The
Then which
ahead, the first
one?
one was I, that is current. The first value was 0.04, 0.
0.04. Yes.
0.079,
Zero. That's the highest value. Just give me the least and the highest value.
Can you hear me,
Have
sir?
you seen? Yes. Just give me the lowest and the
The
highest
lowest is
value.
the lowest is 0.04, sir.
What's the highest value?
0.25.
0.04, 0.25. So, and you have about, I think, 11 lines. So you go with 0. 0.1, 0.15, 0.2, 0.25, then 0.3. So you can use 4 centimeter represents 0.1 unit. 4 centimeter represents 0.1 units. Is that taken?
Yes, sir.
Good.
And the other one is bearing 2.1, 4.0, 6.3, 7.9, 10.0, 12.1.
Just give me the lowest and the highest value.
The lowest is 2.1
Yes.
and the highest is 12.1.
12, right?
Yes, 12.1
So
and
for this
2.1.
one, use 2 centimeter represent 2 units. So it's going to be 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. 2
Taking.
centimeter represent 2 units. Yes. So we continue from there tomorrow. Is that taking?
Yes, sir. Thank you very much.
God bless you, brother. You are welcome. Thank you for paying
But,
attention.
sir, my challenge
Yes.
has remained what I've been complaining, sir. I'm
Yes. What
bothered
is it?
that they will not provide for me all these apparatus. Even in our chemistry practical, they did not provide for us. Did not provide. We did not perform the practical. I have to ask the chemistry teacher to give me his endpoint so that I can derive my table.
Okay.
That's the challenge.
Now for physics, for light, usually it is from air to glass. So tomorrow is because of they don't want to provide you the apparatus. So tomorrow I will tell you a way to manipulate for light. Is that taking?
Okay, sir.
I will tell you because of this challenge. I will tell you how to manipulate for light.
Okay, sir.
God bless you, brother. Have a wonderful night.
Thank you, sir. Good night, sir.
Welcome. Thank you.